Hi, this is Kassian from Instaclustr by NetApp. Today, we're going to learn enough to chat about OpenSearch. This video is part of a series called Learn Enough to Chat About Tech. To see our videos on Apache Cassandra and Apache Kafka, there are links in the description. Like and subscribe to be notified of future videos in this series. Today, we'll talk about what OpenSearch is, the history of OpenSearch, go over some features, and talk about use cases. We'll start by answering the question, what is OpenSearch? OpenSearch is an open source search and analytics engine built on Apache Lucene and comparable to Elasticsearch, and also allows you to search and visualize your data with a dashboard suite comparable to Kibana. While OpenSearch is commonly used for powering search engines, it can also be used to centralize logs and detect anomalies in data being searched. Next, we'll go into the history of OpenSearch. The OpenSearch project started in 2021 when Elasticsearch changed licenses from Apache 2.0 to the server-side public license. The AWS team forked Elasticsearch 7.10.2 and created OpenSearch under the Apache 2.0 license. As of this recording, OpenSearch is compatible with most versions of Elasticsearch. While currently only AWS employees hold write access to the OpenSearch code repository, they encourage and accept pull requests from anyone. As of this recording, the latest version of OpenSearch is 2.15.0, released in June 2024. Next, I'll cover how OpenSearch works. In order to talk about how OpenSearch works, I'll need to cover some terminology. A node is any machine running OpenSearch computations or storing OpenSearch data. You can subdivide tasks between nodes for further optimization. A cluster is a group of nodes working together on the same tasks and dataset. A document in OpenSearch is the atomic unit of data stored. It is a JSON representation of a piece of data. An index is a collection of JSON documents representing some data. For those in the relational or NoSQL database world, think of tables or document stores. Mappings are a collection of fields that the documents in an index have. For instance, each document could have a time-created mapping for the time it was created. A shard is a unit of indexed documents comprising part of the whole index. These shards are distributed across multiple nodes. There are different types of shards. A primary shard represents the original dataset, while a replica data shard is a replica of the primary shard. This is a diagram showing shards and distribution. Each star is a shard. The color is its index. The letter and number combo is a primary or replica indicator and a shard number. For instance, R1 is replica 1 and P1 is primary 1. As you can see by this diagram, due to the distribution of shards across nodes, even if a node were to go down, you could replicate the data sets with primary and replica shards across the other nodes. Before data can be searched, it must be indexed. Indexing is the way OpenSearch stores data to ensure efficient and accurate searches. The result is an index. How you index your data is very important in the OpenSearch ecosystem. It is how you access data and how you tell OpenSearch where to look for data. You can use mappings to enhance your indexing and search experience. Links to learn more in the description. One of the easiest and most common ways to search for and work on data, as well as interact with your open source cluster, is the REST API. You can interact with it using nearly any programming language, as well as utilities like curl and postman. You can retrieve, edit, create, and delete data from indexes using the REST API. One of the many things that makes OpenSearch an interesting technology is its distributed architecture. OpenSearch nodes in a cluster each contain a set of shards, some primary, some replica, all representing an incomplete dataset. Your dataset may be stored across multiple machines that may not even be co-located. As I mentioned earlier, you can delegate OpenSearch tasks between specific nodes. You can use this to route tasks efficiently. Storage tasks can go to machines with fast and large drives, while computation can go to machines with multiple CPUs or even GPU acceleration. This is another way that OpenSearch can claim to be a distributed technology. To search your data, OpenSearch uses Apache Lucene. The search uses the indexes created for your data in order to quickly find what it needs. This is why indexing is such an important subject in the OpenSearch world. Now we'll talk about OpenSearch features. K-nearest neighbor, or KNN search, is available on OpenSearch via the KNN search plugin, link in the description. This allows for applications like recommendation systems, anomaly detection, and more. For more on KNN search, see the link in the description. OpenSearch has the concept of anomalies. From the OpenSearch docs, linked below, an anomaly is any unusual change in your time series data. OpenSearch can automatically detect anomalies in your time series data with the anomaly detection plugin. which by default uses the random cut forest algorithm. See more in the links below. When you're dealing with time series data in OpenSearch, prioritization of new data over old data is a factor. Sometimes you want to scale down replicas or delete indexes over time. Index state management allows you to do this by defining policies that handle periodic administrative operations. These policies are triggered by the change in the index size, the number of documents, or the age of the index. Now we'll talk about OpenSearch use cases. One of the most common ways to use OpenSearch is as a search database for a website or other document store, converting the pages and documents from the store into OpenSearch documents and using full text search capabilities. We talked briefly about anomaly detection as a feature of OpenSearch, but this is also a use case. Say you have a series of operations logs, and you want a warning if any anomalies are detected. Using the anomaly detection and alerting plugins, links in description, you can create a system that sends an email or makes a webhook API call when an anomaly is detected. You can use the OpenSearch Observability plugin to create an analytics dashboard for your data. It has its own query language called the piped processing language. You can also aggregate and visualize data from multiple sources, such as the performance at each level of a stack or web application, or multiple social media analytics streams. Today, we covered a lot about OpenSearch, starting with the fact that it's a search and analytics engine. It started in AWS in 2021 as a fork of Elasticsearch. OpenSource has a robust plugin interface with plugins for KNN search, anomaly detection, alerting, and index state management. Finally, we looked at using OpenSearch to power search for websites or document stores, detect and alert to anomalies in time series data, and as an analytics visualization tool. I hope you enjoyed this video and hit the like or subscribe button if you'd like to see more in this series. Next, we'll cover machine learning.